And welcome back. As the saying goes, when it rains, it pours. And when it rains, well, what falls from the sky impacts every aspect of our lives, from disasters to crops and even diseases. NASA is releasing a brand new study that's into changing weather patterns and how that's changing in an effort to protect our future. Joining me now, live from the Goddard Space Flight Center, is NASA scientist Joe Munchak. Hey, Joe, how are you doing this morning?
I'm good. How are you?
Doing great, doing great. Okay, so NASA's learned from 20 years of looking at data. You know, you're looking at rain and snow and things like that. My first question is, are there clues in looking at all that data as to what our climate future looks like?
Well, what NASA's released is a 20-year-long record of precipitation all over the globe. And this is at unprecedented resolution in both time and space. And so what we can do is we can look for patterns like the seasonal cycle, and we can look for trends over time and how precipitation is changing and how it's distributed. So one of the things that we start to see in this record is the general trend for wet areas to get wetter and dry areas to get drier. That's open to some interpretation, but it does seem to be borne out by the data. And we also can see the seasonal patterns, such as the El Nino Southern Oscillation, show up really well, and that's where the Western Pacific gets drier, the Eastern Pacific gets wetter, and that affects weather patterns not just in the Pacific but all across the globe, as I'm sure you're aware.
Yeah, you know, it's really interesting, Joe. So it looks like the weather patterns are getting more extreme. Like you said, places are drier, places are wetter. Is that because the atmosphere is warming up?
Well, it's one of the things that you expect with climate change is that you will get an increase in precipitation extremes. Warmer air can hold more water, and so you would just generally expect there to be more precipitation, but you don't just need more water or more humidity in the air, you need a forcing mechanism to bring that air upward and condense that water out. And so how that changes is a more interesting phenomenon that's a little harder to track than the temperature, but we do see it in our data set for sure.
Yeah, Joe, that's very interesting. What do you think about South Texas? Anything particular about the southern part of the state?
So we can also use our data set to explore regional precipitation patterns. And one of the really interesting things that we can do with this data is look at how precipitation fluctuates throughout the day. With 20 years of data, you can smooth out all the individual storms and you get these generalized patterns. And so what's really interesting is that you probably expect there to be afternoon thunderstorms, and we see that in this data set during the day. We see precipitation over land, but that reverses overnight, and there's actually an increase in the storm activity over the Gulf of Mexico.
Yeah, it's just amazing what all you can find out from that data. Real quick, Joe, also waterborne diseases, you can tell us something about that as well.
Right, so there are tremendous applications to this data beyond just weather forecasting. We know that when there's a lot of rain and maybe not even flooding, but just a lot of stagnant water in an area, that can contribute to increased mosquito populations, and a few weeks later you get an increased prevalence of mosquito-borne diseases. And so a lot of public health authorities around the world use this data because it is a global data set. It's not just restricted to one country or over land. We have it everywhere, land and ocean, seamlessly.
All right. Well, Joe, thank you so much. Appreciate you being with us this morning.
Well, thank you.
All right.